get-together every year where we just shared in small form the research we were up to, so that we could make sure we're up to date with each other, and also we wouldn't miss these collaboration opportunities that might be sitting there right in front of us.
So to understand whether or not women in Kenya are able to participate in these projects and how that may be different from men or women, I partnered with the Kenyan Agricultural Carbon Project in Western Kenya to identify some of these different barriers and benefits.
We were tasked with going out and talking to these farmers and figuring out what motivates the early adoption of eco-labeling. Those firms that believe that environmental practices are unique resources for them, that they get competitive advantage off of them. You need to be able to drive the diffusion of sustainability through initiatives that allow these producers to communicate their key practices.
We get to ask the question, what structure is more optimal for governing water quality within the Lake Champlain Basin? And we ask you to think about what are the characteristics of these networks that may work more effectively than others.
So the relative risk model is a really effective management tool for decision and policymakers. Stakeholders are engaged. It's vital for their involvement for the problem formulation phase, and that way the results also can cater to a number of different perspectives. And more than anything, this really offers that initial step of beginning that dialogue of tackling some of these complex systems and tricky environmental problems.
So the model can essentially run enormous amount of scenarios, and we are pitching this model as a decision support system where the policymakers and decision makers, they can run this model to see that if they want to change the institutional route from one to another, what would be the outcome?
I think that the wash of big data that we're in now can really help us figure out this relationship between nature and human well-being. Already people have used these sorts of data to estimate the home range of people, to predict flu outbreaks better and faster than CDC can, and to predict park visitation rates using the photographs uploaded to Flickr. So there's all kinds of ways we can now measure in a quantitative way behaviors and social science attributes that really can let us unpack this relationship between nature and human well-being.
Multi-tiered project, multidisciplinary, all happening because of the great work of the Gun Institute.
My lab has done a lot of work on disturbance effects and how those influence ecosystem services. And we know that forest structure and function is shaped over time by the compounded interactions of finely scaled natural disturbances superimposed on periodic intermediate intensity disturbances. Forest ecosystems are dynamic over time and space. The services they provide will vary accordingly. It's best whenever possible to model your forest as a dynamic system.
We know that there's currently too much carbon dioxide in the atmosphere and along with other greenhouse gases. And we also know that trees remove some of that carbon dioxide and sequester it. What we don't really know is whether the species diversity of those trees matters to the carbon sequestration potential of that system. Ecologists think that it might, for two reasons. First, more species with varying resource needs might mean that resources such as light and nutrients are used more fully, and thus the system is more productive. It could also be that more species means a greater chance of key species in the system, key highly productive species. Thus the system is more productive and sequesters more carbon.
Amazon, Congo, and Borneo too, everyone's singing the commodity blues. As livestock, palm oil, cocoa, and soy expand, millions of forest hectares baby demand.
In Kentucky, compared to 2008, 20% pollinator abundance decreases. And most decreases happen in agricultural area, not the forest area. And once we validate this model value with actual observation of pollinator abundance, then we can produce maybe productivity demand for blueberry based on the demands of pollinator abundance, or we also may produce conservation map which is indicating which area is more valuable than other area for conserved pollinator abundance.
So this is just an example, a little vignette of, I think, what the gun can do in action. We are a super team all together, and hopefully we'll bring some more of you all into the fold. Thank you very much.